Hello, this is Mr. Wynn, and today is solving three variable systems of equations. So like system equation in two variables, system equation in three variables can have one solution, infinite solutions, or no solution. The solution to a triple system is an ordered triple instead of an ordered pair, x, y, z in that order. Below are some pictures for each type. You could have all three planes intersecting at one point, and that's it. So that's one solution, consistent, independent. You could have infinitely many solutions, so these three cross this red line right here. Or they could be the same plane all on top of each other, like overlapping. So that's consistent, dependent. And there's no solutions. All three planes could be parallel, not crossing all three at the same time. Or maybe two parallel and one goes through both of them, or they give me that triangle shape. But we don't worry too much about the graphs, we care about solving. To solve by hand, we use the same techniques as before. We're going to use substitution or elimination. Again, elimination is the best method. Substitution will have lots of fractions. And regardless of which method you pick, it's going to take about half your page. Our process is to do elimination to turn three equations with three variables into two equations with two variables. Then it's like last topic where you had a regular system, two variables, two equations. You can use those two to get a new equation with one variable. So one equation, one variable. And if it's one equation, one variable, you solve like normal. Once you have your first letter, you plug it in to get your second letter, then you plug those two letters in to get your third letter. Alright, so again, three equations turn to two equations, turn to one equations. Same for more. If it's four equations, you can turn three equations, turn two equations, turn to one equation. And always plug in backwards to solve for each letter. So here's the first problem. Here's a triple system, x, y, z. There's three equations. Make sure you're very organized. I like labeling them. This is equation number one, equation number two, equation number three. You're going to pick a letter and do elimination. I like y. I like y because y is by itself. I can change that one y into anything else. I'm going to do equation 1 and equation 2 together. Since equation 2 has positive 4y, I need to see equation 1 with a negative 4y. Again, same numbers, different signs for elimination. So I'm going to multiply this first equation by negative 4. I'll distribute everything. So that gives me positive 20x minus 4y plus 16z equals negative 240. The second equation is fine, so I'll leave it alone. It's 2x plus 4y plus 3z equals negative 12. Alright, and now I do elimination by just adding straight down. Whatever signs what you do. So 20x plus 2x is 22x. Negative 4y plus 4y cancels out. 16 plus 3 is 19. The z, and then negative 240 minus 12 is negative 252. Alright, I'm going to label that equation number 4. So that's one of my new equations with only two letters. I'm going to do the exact same thing, but I need to find a fifth equation with two letters. So I just use equations 1 and 2. I now have to use a new pair. I can use 1 and 3 or 2 and 3. Now 1 and 3 better because 1 has a single y. I can make that match this 3y easily. Since the bottom has a negative 3y, I need a positive 3y on top. That means I'll multiply the top equation by positive 3. And distribute. So 3 here, distributes everything. I get negative 15x plus 3y minus 12z equals 180. Other equation stays the same. 6x minus 3y minus 2z equals negative 52. Then I do elimination by adding straight down. Negative 15 plus 6 is negative 9. Y's cancel. Negative 12 minus 2 is negative 14. That is 128. That's equation 5, I mean. Alright, so the first three equations had three letters. Those three equations turned into two brand new equations with two letters, and now it's just like last time where it's a system of two equations, two variables. I'll make the x's match. I'm doing elimination. The first time 22 and 9 match is pretty big, so you use the calculator for this part. I'm going to multiply this first equation by 9 to get a positive, whatever that is. I'm going to multiply the second equation by 22 to get a negative, whatever that number is. So if I distribute the first one, I get 198x plus 171z. And that equals negative 2268. I distribute 22 to equation 5, I get negative 198x. They're matching. I get negative 308z. That's supposed to equal 2816. I can now do elimination. The x's cancel. That makes a negative 137z. And that makes 548. That's now our sixth and final equation. So our sixth equation came from equations 4 and 5, but went from two variables, two equations, into one variable, one equation. This last equation is solvable by one step. All I gotta do is divide by negative 137. And I get z equals negative 4. Once you find one letter, you're mostly done. Just start plugging in and going backwards. I'm going to go back to equation, which one's easy? Equation 5. I'll plug in z there. So it's going to be negative 9x minus 14 times negative 4 equals 128. I can just simplify. That's negative 9x, negative 14, that's plus 56 equals 128. I can subtract 56. I get negative 9x equals 72. I divide. I get x by negative 9. I get x equals negative 8. I found x and z. All that's left is to find y. To find y, you use one of the original three equations. I'm going to plug both x and z in. It doesn't matter which equation you use, but I'll use the second one. The numbers are kind of small, that's why. So it's going to be 2 times negative 8 plus 4y plus 3 times negative 4 equals negative 12. I just simplify. That's negative 16 plus 4y minus 12 equals negative 12. Combine like terms. So that gives me 4y minus 28 equals negative 12. I'm going to add 28 to both sides. 4y equals 16. Then I'm going to divide. Y equals 4. So we found x, y, and z. Combine them all together for a single coordinate. So x was negative 8, y is 4, z is negative 4. That is my answer. If you're going to classify it, that is consistent and independent because it's 1 point. And you can plug this point in all three equations. It should always be true. So that's how you solve a triple system. And like before, there are times where you get no solution and infinite many solutions. You just do the steps again. It's actually a lot shorter because, again, the letters, multiple letters will cancel it out at the same time into just one at a time. But you'll get either something false or something true. So if you get something false, for example, 0 equals, or is there something true? 0 equals 0, and that's true. That's going to be infinitely many solutions. And you could classify that as consistent because there were solutions. And then how many? It was infinite, so you can say dependent. Or you might end up something false, like 0 equals 8. That's false, so you can say no solution. And the classification for no solution means they're parallel, they all don't cross. That's going to be inconsistent. So I'm not actually doing these last two problems, but one of them is going to be true, one of them is going to be false. All the letters are going to cancel out. You can't actually go at a single x equals or single y equals or single z equals, or in the bottom case, what r equals, s equals, or t equals. And that's it. Hope you enjoyed the video. Make sure you ask questions in class. See you soon. Thanks again. Bye.